Okay, so there's axis symmetry, sure. Another way we could describe axis symmetry is there's an imaginary, invisible line where the left side and the right side of that is perfectly equidistant. So this point right here is equally distant from that point right there, whatever that point might be. Same with everywhere else on the parabola. Anyways, let's move on. So that would be A, that would be B, roots slash zeros slash x-intercept slash solutions. Jonah.
The two dots on the X.
The two dots on the X, X, thank you. Okay, so these would be the zeros. I'm going to put a little star next to this one, because by pure definition, that's the x-intercept. But sometimes, depending on the word question or the scenario that I give you, it may not be the same as a root. The root is like another way of saying it's a solution. It's the answer. The x-intercept is the actual point. So sometimes the answer is right here. Sometimes the answer is represented in a different way, but we'll get to that, I think, in 1.5. You'll see what I mean in a little bit. And y-intercept, we got Nathan?
Yeah, it would be the one on the Y-axis.
That one point on the y-axis. Thank you for describing it in that way. That will be the y-intercept. Okay. Minimum slash maximum. Clara? Yeah, Clara?
Yeah, I remember learning it like.
Well, in the English language, what does a minimum mean?
The amount of something.
Sure. So on this graph, what would be the least amount of something be? What would the least value be, the lowest value? It's a question. It's a question. Give me your best answer. Your final answer. Okay, okay. Now you're using your brain. It's not a memorization. You're looking, you're trying to analyze. This is what I want you to do in math. This particular graph goes on forever. So it would be foolish of us to say that there is an absolute minimum value. There is no minimum. In fact, for this parabola, there is a maximum. This happens to be the maximum. There is no minimum, but there is a maximum. How do I know? Well, it's inverted, it's upside down. If I drew a regular parabola, this is what you're familiar with. There is no maximum, but there is a minimum. That's all it is. And so take a look at today's sheet. It says 1.3, maximum, minimum values. What do you think I'm going to be talking about? Which one of these five do you think I'm going to be talking about? I want two answers. One's obvious. I'm going to be talking about this. But what else, Emily, does this coincide with? No. Look at the image. Yes. The max or min is simply the vertex in a particular scenario. If it's upside down, I'd be talking about maximum. If it's right side up, I'd be talking about minimum. But min-max and the vertex essentially is virtually the same thing. Okay? Now let's get to standard form, vertex form, and factored form. So this I'm going to take over because some people said I don't remember at all. These three words refer to the different ways we can write a quadratic equation. All three, as you can see the arrows, they can be interchanged. They could mean the exact same thing, but depending on how I give it to you, you can pull out information right away. For example, if I gave you the question in vertex form, so you might want to put a little bracket on your handout. Look for this one. You see this on your handout? You might want to write, this is vertex form. I'll do that on digitally as well when we get there. But if I give you something in vertex form, Do you remember the values h and k being special? Remember that? Emily, I'm going to pick on you. Do you remember that part? Sort of. Okay. If the equation gives you in this form the value that's subtracting the h or adding the ph, and the value that's outside of the entire function, automatically tell you what the actual point is. That's why this form is sort of special. That's why we call it vertex form, because it gives us the vertex right away. This form, the one with the brackets, you might have seen before. When did you end up with two binomials multiplying with each other? Every time you factor it. Every time you factor. So that's what we call this factor form. You can write that underneath as well, just to remind you. And factor form automatically gives us 2 points, and it's that could equal a 0. So instead of the y value, what we can do is, what if the y value was 0? What would the x values have to be? It's the same idea as factoring, but we apply it to graphs. We'll get there. All right? So it gives you the zeros very quickly. We call factor form. Okay? The standard form is standard. It's like the normal form. I guess you can think about it that way. It doesn't give you too much information, but there is a way to go from here to here to get vertex form. There is a way to go from here to here to get factor form. And if you can go from one direction to another, of course, you can reverse it. All three are interconnected in one way or another. Let's recap to see how much you can pull out. Anyone know how to go from here to here? We just said it. After Harriet. Lucas? There you go. If I want to go from here to here, you factor. How would I go from binomials into a trinomial? Louisa? How do I go from here back to a trinomial? Expand. Right? You do distributive property. And these are two skills you already know. In the same way, if I gave you something like this, I'm pretty sure you can go back here by doing distributive property and multiplying out. You just expand and you multiply it out. So the question remains, how do you go from here to here? There's a small section in grade 10 you might have learned, but you might not have liked, and therefore you might have forgotten. And you want to remember how to go from standard form to vertex form. Luke, you remember?
Yes.
What is it called?
Is it the quadratic formula?
Oh no, that's something else. That involves the factor form. That's close, right? Quadratic formula is when you have this and you can't factor, your last resort is to use this technique called quadratic formula. You remember? After Louisa, Zane?
I have the slightest clue.
Huh?
I have the slightest clue.
That's okay. That's okay. Carson, do you remember?
Completing the square.
Did you look at the sheet? The first thing we're going to look at today is completing the square. Okay? Our goal is to try and recap grade 10 so that this becomes very smooth. Some people hate this. They just absolutely hate it. So I'm actually going to show you another way to get the vertex that might be nicer to your brain. Yes? Yes. Yes. Came a little later.
Good morning, Northern. Just to let you know, there's going to be some testing done on the valves over the next little while, so please ignore them. We'll continue to 12:30. Thanks.
So, just quick recap. The whole point of completing the square, the whole point of getting vertex form is to get what useful information? To get the vertex. But people hate this. And once I do, you might remember. You might be like, oh yeah, I remember this. So I'm going to show you something else. It's called partial factoring. as another technique. So our goal for the first session is to at least know how to do it. It might take you a long time, but again, as you get more and more practice, the speed kicks in. For now, let's make sure we know how to do it. Okay? Where is my handout? All right, let's do this. This one. Okay. Okay. Can you believe this is the norm? Can't believe this is the norm. It's so weird. Okay. And share screen. All right, let's do this. I don't need to see my face. No, thank you. All right. Rotate. Let's put that here for now. Okay. So we have with me, what did we write so far? We have factored form, standard form. I asked you to copy down factored form, standard form, and vertex form. Right? I forgot to mention how for every single one of them, you might want to write this down. For every single form, the value of A doesn't change. Did you notice? Every single form has an A value in front of it in one way or another, and that will help you identify whether it is, if it's a positive value, that's a plus VE, positive, okay? That means it's right side up. And of course, if the A value is a negative, it's going to be upside down. So no matter what form you get, you can take a look at the very first value, like the x squared value, right? And look at the coefficient, check if it's positive or negative, and that will tell you exactly what direction it's moving. Any questions so far? No? All right. So I'm going to go straight up into showing you how to complete the square. There's going to be some instructionals. So I'm going to do the math. I'm going to type an instruction piece in case you want to, memorize the steps or whatnot. Okay? Completing the square. I apologize in advance. Step 1. What you are going to do is first, we're going to focus on the first two terms. I want you to put the third term aside. So I'll write, put aside the constant. How about I start with a star? Please put aside the constant. And, because you're so good at mental math, while you put aside the constant, I would like you to also common factor the A value on x squared. And this is what it looks like. So I'm going to focus on the first two. I'm going to common factor the negative 2 out, leaving me x squared plus 3x. I'll use a different color. And the 11 is just moved aside. You get what I'm saying? Okay, so a positive 1 is just moved aside. And the negative 2 is factored out. So far, so good? So there's nothing illegal, and I'm just manipulating numbers, but that's part of the technique. Okay? Yes?
Why didn't you factor -2x?
Very good question. The whole goal of completing the square is this. I'm just do it here. Oops. Okay. The whole goal of me doing all of this is to turn it into a perfect square. Like here. And then I think you get the point. Okay? When I expand any binomial that's squared, I always end up with an x squared, some number that I added, some number that I multiplied, right? The whole goal of completing a square is what? Do you know? At the end of the day, do you know what I'm getting? We just mentioned we're getting the vertex form. It's this. Here, let me move it. It's this part right here. And what does that have? A binomial squared, right? So if I'm trying to create a binomial squared, my goal is to have a perfect trinomial. I want one of these. Because when I have one of these, I can turn it into a binomial squared. That's my goal, right? If I really want to turn that into vertex form, that's the whole purpose. So just hold up for a second. I know I mentioned this. I'm going to come back to it later on. You'll be like, oh, okay, so he had a reason for all of that. Just factor out the a value, nothing else, okay? Wow, this is annoying. I'm going to just do that. All right, so next step is I'm going to take this middle value and I'm going to create a third term to make this into a perfect square trinomial. How do I do that? It's going to involve, this is weird, if I want to turn this into a perfect square trinomial, you're going to take this middle number, divide by 2, then square it. That is how you will get the perfect square. I shouldn't have erased it, but all the examples that I showed you, take a look at the relationship between the middle number, middle coefficient, and the last one. 2 versus 1, 4 versus 4, 6 versus 9, 8 and 16, 10 and 25, 12 and 36. What is the pattern? Divide by 2 and square. Take 2. 2 divided by 2, squared. 4 divided by 2, squared. 6 divided by 2, squared. 9. 8 divided by 2, squared. 16. 10 divided by 2, squared. If you want the perfect square trinomial, you take this number and you divide by 2 and square. So 1.5 squared, cheating, 2.25. I just did something illegal. That's it? Yes, but right now the left and right, there is no left and right. This is just the value of y. I can't do that. So if I add the number, I legally allow that to happen by subtracting. I added a 0, that's what I'm doing. Stupid, huh? But this is part of a technique and you'll see that it works out at the end. Okay, so let me write that as a step. Divide the b value, so in this case a 3, by 2, then square to get the third term of perfect square trinomial. And that's an 11. Okay, so I have how about I use a different color? Yes. Okay, you have to add and subtract it for sure. Next, after that, the three terms here I like. We like this. This can make a binomial squared. So how do I get rid of this? We literally just take it out. Okay, so the final line is this. Don't rush it. Please take a look at what I'm doing. X squared plus 3x plus 2.25 plus 4.5 plus 11. Why? Why? Yeah? What's up? Yep.
Alright, so basically, inside the bracket, it's multiplied by the -2. To bring it out, you have to multiply by -6.
1 second. All right, everyone. I know that I said I'm subtracting a 2.25, but am I actually just subtracting a 2.25? This entire bracket is affected by a multiplication of -2. So if I leave the bracket, well, it has to appear in its true numbers, right? Think about distributive property. If I were to get rid of this bracket, what's happening? -2 has to multiply into everything. These three numbers, they're still part of the bracket. I'm not going to multiply. I'm not going to do distributive property. But that last one, because I'm removing it from the bracket, I do the distributive property, and it becomes multiplied by the a value. Yes, David?
Can you not combine 4.5 and 11?
I'm getting there. You're too fast for me. Okay? And now that we're done, I'm going to jump the step. Okay? This part, highlighter, highlighter, highlighter. This portion is going to factor perfectly. It's going to turn into, I'm not just doing this in my head, there's a trick to this. This becomes x plus 1.5 squared plus 15.5. How did I get 1.5? Yep. Yeah, essentially. This number adds by itself to get 3, and it multiplies by itself to get 2.25. Remember the factoring idea? I need two numbers that multiply to 2.25 but add to a 3. So an easy way to do it is take the 3 and divide by 2. You get that number. Or you take 2.25, you square root it, and you get this number. Either one's okay. All right? Now, hopefully you're following with me. Jonah, take a look. All that work was so that we can turn it into a trinomial, right? That's why I didn't take out the x squared. I didn't take out the x. I need the x squared there. That's why. And lastly, now that we have vertex form, you remember what we said about this number and that number? Those two numbers automatically give us the vertex, or the maximum or the minimum. Negative 1.5, 15.5. That's the vertex. Does everyone remember how when the number, so the number that's affecting the x is a positive, it's actually moving to the left side, it's a negative value? Remember that? Just put a little asterisk next to it. Pop quiz. Where was I? I think I was at Emily. So, period. Here's a vertex. Is that vertex a maximum or is that vertex a minimum?
It's a maximum
How do you know?
because it's a -2.
Thank you. That's it. So we would say it is a maximum. That's how we know immediately. The whole goal, by the end of this year, my hope, my dream, and my goal is that you would look at an equation and you can visualize the image in your head. Why? It makes it that much faster for you to discuss it and talk about it and apply it to different factors like science, like business, like whatever else the math applies to. Okay? Why are we learning math anyways? If it's because the government tells you you have to, then I'm sorry you're here. But ultimately, the main thing that I want to tell you about math is this. If there is a purpose or a need in the outside world, then we have to be able to do it in math class. If there's a math for it outside, anywhere, science, business, art, anywhere. If there's a need for numbers out there, it has to be possible in math class. It has to be possible. I have a picture that I want to show you. And I think this is so true. Not because I'm biased, but because I think it's true. Okay? Name, dog walker, math. Is it show? I think it's this one. No, 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 no. Can't find it. I don't know. Someone sent it to me. I thought it was the greatest picture of all time. But looks like I can't find it, and this is being recorded, so I'm just gonna close this early. The idea was this, right? Someone wrote. Would you stop? Someone had this person walking labeled as math, and every other subject in the world was labeled as these dogs. Okay. There's another picture from XKDC, I think, where it's like, you know what? Let's see if you. Do you get this? Do you get this joke? Oh my gosh. Okay. You get this joke? Ready? We have sociologists, right? People who study social studies. People study the interaction of people, so on and so forth. There's a smart guy here that says, sociology is just applied psychology. Application of how people think in their brains. Psychology. And there's a biologist that says, psychology is just applied biology. Because the brain is part of the human body and there's chemicals and stuff that's involved. Which is true. And a biologist right next to it is a chemist saying biology is just applied chemistry. The biology only works if you understand atoms and neurons and how neurotransmitters fire in your brain. And then there's a physicist saying, well, what does that person say? Oh, the physicist says, which is just applied physics. It's nice to be on top, which is true. If you don't even understand motion and interaction of physical atoms coming together, then there's no way we can understand chemistry. And then way at the end is a mathematician. It's like, hey guys, I didn't see you guys there. Right? Math is, if there's a need for math outside, whether it's in art, whether it's for money, whether it's population and history, whatever, we have to be able to do it in its raw form in math class. That's why we learn it. And so if you've been memorizing math all this time, I'm sorry you had to go through that. Math is actually supposed to be useful in everywhere outside of this classroom, which might be depressing. Let's try this out. Okay, let's try this. Keep going. Sharing screen. Going back to this. All right. So using the steps that we just talked about, could you try B for me? Okay, I'll give you like 3 minutes. There should be a bunch of notes that you might have written on the side. If you didn't, that's okay. Okay, I will try to remind you as you go. I would like you to tell me what the vertex is, and as a bonus, tell me whether it's a max or min. Yes.
And for A, you split to B, try to reduce the max or min because of the A value?
Yes. So we saw that it was a -2, which means it has to be flipped over. Okay. Oh, because I don't want people making a silly mistake and ruining all their calculations, let me factor out the first term for you. When you are factoring, are you multiplying or dividing? When you're factoring, you're dividing out, right? So what is 4 divided by half? Huh? 8. Yeah, I suppose must is it. So if you weren't quite sure, you can use your calculator, but you also know that if you're dividing a fraction, you can multiply the reciprocal. This becomes 8x minus 1. Okay? I put that example in there because I didn't want you to mess up in the future. Try that out, and then move on. Using the middle number, divide by 2 and square. Try to turn it into a perfect square trinomial, and complete the square for me. We're almost done here. I'm going to give you some more applications, and then we'll talk about, we'll do some more harder word questions together, and we'll have our break, okay? Hang in there a little. Maybe another minute? Everything is perfect. When you bring the -16 out, it gets multiplied by the half. Multiplied by the half. Okay, not sure how far you've gotten, but remember, this is supposed to be a grade 10 skill. And so if it's taking a little longer than planned, keep working on it. Okay? The speed will come. You've got half, divide by 2 and square, that's a 16, but that's illegal, so I'm going to subtract by 16. And then I'm going to remove the -16 because I only want the 3 numbers here. If I remove the 16, it gets multiplied by the half, so it becomes -8. I am going to quickly factor because I'm lazy and I don't want to write more than I have to. I'm just going to take the 8, divide by 2, or you can take the 16 and square root it. 9. Vertex is -4, -9, and it is a min. So I did that in, I'm going to say about 30 seconds. If this was a normal semester or a normal term school, and I'm writing tests for you, In the grade 11 level, I would expect you to take about 2 to 3 times longer than I do on a typical test, a typical question. So a question like this, I would expect you to be able to do in about 2 minutes, easily. Yes? Yes, the thing inside, there's a couple of ways I can describe it. I don't have time to explain the reason why, but think about it this way. The default equation is a negative h. It subtracts with an h. So if this is written as a positive, h must be a negative 4. Yes. So so the vertex is a negative 4 here, and it's written as plus 4. So we just switch the numbers. The best way I can describe it without going into like why this changes the x value into a negative and so on and so forth. Okay? So now that we're at this point, who finds this? Oh no, let's not do partial factoring yet. Please turn to the very back of the page. So I'm going to try to make a connection of why we try to find the vertex. Let's be honest here. Okay, this is very blank. You don't have to do much. I'm just going to draw some pictures to show you where max and min and finding the vertex essentially comes in handy. I'm sure you've seen in grade 10 before, like projectile motion. Like for example, let's say there's a person that's standing on a castle, and then they have like a bow and arrow, and then they're fighting a dragon. Okay. Okay? And it's like blowing fire and stuff, right? And you're trying to shoot it and you're like, oh, will it hit the dragon? Because that's obviously a real life problem that everyone's going to face sometime in their life, right? So, sometimes you need to know what the highest point is. Sometimes you might need to know what the point they're dropping is. But essentially, distance versus height, right? You might have a question like that. Or something a lot more complex in the real world. I don't know, right? Something that comes in very handy in the world of finance. When you want to increase your profit. You want to put more money in your pocket. Hey, that rhymes. I'm amazing. You have time, you have money, and as time passes, maybe when you're starting a business, you're actually in the minus when it begins. But as you work on it, you're finally breaking even, and then it goes up, and you're like, yay! But as more time passes, maybe the popularity decreases, and your actual profit starts to go down to the point where you're not making profit at all. So you can say, as long as it's in the positive, we're profiting, it's positive, but anything underneath is a loss, right? Math can try to predict your future business plans, right? So if you want to maximize profit, maybe you want to sell your business here and disappear. I don't know, right? That could be one thing. Yeah, everyone's okay? Okay, let's move on. I'm going to go to the bottom section. I'm going to erase all. Does anyone need to copy anything? Everyone's okay? On the bottom, decreasing cost, the same thing. You will often see that most real-life applications is, in fact, upside down. Clearing all. Decreasing cost. Let's see. If we are to, let's pretend that's money. And let's pretend this is the number of items you produce in your factory, right? In the beginning, as soon as you start producing, of course, you're able to sell it, right? But then if you, and it's really expensive to make, but at a certain point, if you make more and more and more, maybe because you're producing in bulk, right? Maybe it's because in bulk production there's a discount, right? Maybe that's a possibility, so the price it costs you will go down. So what you might want to do is use math and avoid the maximum cost that you have to pay to make your business run. Right? Maybe that's a real life situation. Geometric applications, this might not necessarily apply to you, but it does make sense for a lot of certain businesses. Okay, how about like you're in landscaping and maybe this is the length of a garden and this is like the area in which your garden is growing. If your length is 0, then your area of the garden is 0, right? But as you increase the length, you maximize the area where you can plant flowers or you can pour concrete or whatever it is you need to do. But as the length gets bigger, of course, the width will get smaller, and then you lower your area again, right? So maybe you're thinking this is the best bang for a buck. You might use math that way. So I'm just trying to show you that there are so many applications where the max and min become useful in its own way. But it is up to you to use or to know how to calculate that using these little techniques. Whether you remember how to do this in your future life or not, I don't know. But again, if you can visualize this graph, you at least have an idea of what to aim for as you grow up as an adult. That's sort of my goal. Okay? So let's go to that second page. Go back to the back of the first page is what I mean. You may not have liked completing the square. So this is what the graph was supposed to be. Would you try to draw this in for me? There is a dot right at the 0, -1 mark. And then there should be a little gap in the x-axis. Those are actually dots. And there is a vertex around the 0.75 mark. So let me try to draw this in. So if this is 0.5, 0.75 is right here. I'm sorry about that. I totally forgot that this graph was a bit faint. And there is a vertex here. You don't need to know the point. You can just do it roughly because we're going to do the calculation here. Okay, so this section is, you can put a little star next to it saying partial factoring. It helps you with the vertex. Now, there is a little portion that I need to explain. If you don't quite understand it, that's quite okay. But you still need to know how to do partial factoring. That -1, if you remember your transformations, a -1 on the outside of the function simply shifts the function up or down. In other words, it affects y value only. The -1 does not change location of axis of symmetry. Would you agree? Whether I shift this parabola up or down, does it change my dotted line? No. And so I'm going to temporarily ignore the constant, whether it's a -1, -2, I don't care. Ignore the constant and factor the remaining x squared plus x portion, ax squared plus bx portion. Take a look at what I'm going to do. Okay? It's going to be interesting. And this is why it's called partial factoring, you'll see. So I'm going to pretend this -1 is not there for now. If I common factor, Jonah, this is where you come in. Please, fully common factor, please. Yes. Sure. Uh-huh. You can. Go for it. Okay, 6 divided by 4. You can write it as. Just like that. It's fine. Do you want to do 2? Would you feel comfortable with 2 instead? Yeah? You don't care? You know what then? You might not be the only one feeling that way. So how about I common factor what we know, 2, and then that becomes 2x minus 3. Sounds good? All right. If I'm looking for the x-intercepts, remember, if I find the x-intercepts, I can find the axis symmetry. If I'm looking for the x-intercepts, what's the y value? Zero. X-intercepts. Okay. What are my roots? What does x have to be for this bracket to equal a 0? People are avoiding my eyes. Okay, look. 2x equals 0. What does x equal to? 0. Thank you. 2x minus 3 equals 0. That means 2x equals 3. That means x must be 3 over 2. So, 0, I'll just do 1.5. Okay? If this equal to 0, if this entire function equal to 0, then I would have x equals 0 and x equals 1.5. This is where the interesting part starts. X equals 0 and x equals 1.5 are equal distances from the axis of symmetry, just as if I was talking about the real x-intercepts. Okay? You know what? I'm going to lose you. Don't worry about it. Take these two numbers, average them. Okay? Average 0 and 1.5, which is what? 0 plus 1.5 divided by 2 is 0.75. What does that mean? It means the middle of 0 and 1.5, the axis of symmetry. Okay? The axis is x equals 0.5. Oh, sorry, 0.75. How do you find the y value? Well, we have the vertex, x value. Think of chapter 1.2. If you have the x value, huh? You don't make it a 0, you just plug it in. What is f of 0.75? What's the y value when x is 0.75? I'm going to plug it into this. I already pre-calculated it. It's 4 times 0.75 squared minus 6 times 0.75 minus 1. The value of this is negative 3.25. The vertex is positive 0.75 comma negative 3.25. This is the first time you're seeing it, so it might be a little bit confusing. But I'm going to try to, all of this, I'm going to try to simplify as best I can. Okay? And some of you are copying, but I'll say this. Ready? Take your equation, take the first two terms only, and factor it. Whatever zeros you get, you will average it, and it will give you this line. Take that line, take the number for that line, take the value of x for that line, and then figure out the y value by plugging in, and you found your vertex. let me write a little thing on the side. Some of you might be copying. This will be available, the fully filled in copy will be available online in just a second. Or actually, it's already online. I'll write it here, okay? Step 1. Common factor, the first two terms only. Ignore constant. That's first step for partial factoring. Okay? 2. Identify the roots for the factored terms. Okay? Average them. This is the axis of symmetry. Use this value to calculate the y value of vertex. That's it. Can you try that for the next example? Let's go ahead. Take the first two terms. The first two terms is 2x squared plus 11. I know. I gave you numbers that don't divide nicely. That's okay. Keep the plus 5 aside. You don't have to worry about that. Common factor 2x squared plus 11x. Start there. Like so. Oh, I'm going to do this. Okay, so I got this started for you. If you take the first two terms only, right here, take the first two terms only, I common factor, taking out just the x, and that got me two random numbers that happen to be equal distance from the x-axis. Sorry, axis symmetry. Find that middle. Find the axis symmetry. Oh, it seems like I did not resume recording. Oh, that's my bad. We'll just leave this here. See if you can follow the calculations online. The answer key is already online, so pause the video and try to copy. Otherwise, the recording will stop here.